Hello everyone, welcome to this series of mathematics lessons. This is a continuation of the previous lecture. In this presentation, we will study about prime number and composite numbers. Now let us observe this table. In this table we can observe there are numbers from 1 to 12, corresponding factors and number of factors. For one, factor is 1 itself. Number of factor is 1 since there is only one factor for number 1. For 2, factors are 1 and 2 itself. Number of factors are 2. For 6, factors are 1, 2, 3 and 6. Total number of factors are 4. We find that the number 1 has only one factor, that is itself. You can notice 1 has only one factor, that is itself. The number is 1. Factor is also 1. Numbers having exactly two factors, 1 and the number itself, such numbers are called prime numbers. Examples of prime numbers are 2, 3, 7, 11. You can notice the number of factors are 2, that is 1, and the number itself 2 and 2, and 1 is common for all. For 3, the number itself is a factor and 1 is also a factor. For 7, the number itself is a factor and 1 is a factor, and 1 is other factor. These numbers are called as prime numbers. Numbers having more than two factors are called composite numbers. In the table we can notice number 4, 6, 8, 9, 10 and all these numbers have more than two factors. In case of 4, we have 3 factors. In case of 6, we have 4 factors. In case of 8, we also have 4 factors. We can see 4 factors. Numbers which have more than 2 factors are called composite number. We can think of this way. The number is composed of more than 2 factors. This is also a one way of thinking of composite numbers. 1 is neither a prime number nor a composite number. We can find prime numbers from 1 to 100. We can also find prime numbers more than 100 as well with an easier method. This method was given by Greek mathematician Eratosthenes in the 3rd century BC. Now let us see how this works. We can consider Sieve of Eratosthenes method as, say for instance, this is a sieve which is used to sort out the unwanted things. Here the unwanted things are composite numbers. The remaining things that is left in the sieve are prime numbers. This method is called Sieve of Eratosthenes. The method is very simple and effective. In this example we considered from number 1 to 100. We can consider for any number. We can consider 1 to 1000, we can consider 1 to 10,000 and so on. The principle remains the same. Now first let us cross out 1 because 1 is neither a prime number nor a composite number. Next we will encircle 2. We will remove all the multiples of 2 other than 2 itself. We can notice the multiples of 2 are 4, 6, 8 and 10. We removed 4, 6, 8 and 10 in first row. And we can also neglect the whole column of 2 since these all are multiples of 2. Now let us move on to 3. We will encircle 3. We will discard the multiples of 3. The multiples of 3 are 6, 9 and so on. we can rule out some of the numbers in column 3. 33 is a multiple of 3, 63 is a multiple of 3, and 93 is a multiple of 3. Rest all numbers are not a multiple of 3. So these are the prime numbers in this column. Now let us move on to 5. We will discard the multiples of 5. 5, 10, 5 and 10 in this row. And we will discard this whole column since all these numbers are multiple of 5. Now let us move on to 6. The factors of 6 are 1, will not consider 1, 2 and 3. So multiples of 2 and 3 are discarded as well. 16, 26, 36, 46, 56, 66, 76, 86 and 96 all are multiple of 2 and 4. Let us move on to 7. 7 is a prime number. We will discard the multiples of 7. We will discard the multiples of 7 and we can notice 27 is also discarded because 27 is a multiple of 3. For 8, the factors of 8 are 1, 2, 4 and 8 itself. 1 is not considered. 2 and 4 are multiples of 8. We can see all these numbers are multiples of 2 or 4 or 8. So we will discard this whole column. Then we will move to this column. We will discard the multiples of 3 and 9. The rest are prime numbers. This method is really useful when we are actually using or implementing the method of finding prime numbers in computers. Now let us see 2 important facts about prime numbers. 2 is the smallest prime number, which is even. There is no other prime number in whole numbers or natural numbers which is even. We cannot find other even prime number because if it is even, we can obviously divide it by 2 or 4. Every prime number except 2 is odd. In the next presentation, we will study about tests for divisibility of numbers. The content of this recording is borrowed from Karnataka Textbook Society, Bangalore, under Fair Usage Policy. This video is presented by Avvari Technologies. Please do hit subscribe button to get more content. Thank you.